solving polynomial equations. And this time we're going to talk about the irrational conjugate theorem. And so from from video 12, we had two irrational zeros that were conjugates of one another. And that was, we had the negative square root of 3, 1 minus the square root of 3, and then we had 1 plus the square root of 3. That was when we solved to find out what all the zeros were, and that was what the graph looks like there. So when we were doing our work previously, from the graph we had 1/2 and negative 2/3, but then we solved and we came up with our conjugate pair here, which was 1 minus the square root of 3 and 1 plus the square root of 3. And so that's what the irrational conjugate theorem says. It says, let f be a polynomial function with rational coefficients, and let a and b be rational numbers such that the square root of b is irrational. So that's not a perfect square, so we can't substitute in the square root of 9, which is 3. That's not going to solve for this. We need this to be something like the square root of 8. Let a plus the square root of b is a 0 of the polynomial, then its conjugate, a minus the square root of b, is also a 0. So what that means is, if this is a 0, this is also a 0. So we'll look at example 14. Write the polynomial of least degree that has rational coefficients, a leading coefficient of 1, and the given 0. So this part, least degree. When we did the previous example, we had 1, 2, 3 zeros. Now, for example 14, it shows that we have 1, 2. However, we know that we have to add one more, because if we have 1 that is 1 plus the square root of 5, we also have to have the conjugate, which would be 1 minus the square root of 5. So that changes. Now, instead of being a least degree of 2, our least degree for this one, now we have degree 3. So when we finish, we should have a function that has, we should be looking at, for our highest degree with the lead coefficient of 1 when we get done. But we're going to do it the same way that we did before. We know how to make these into a binomial so that they would be a 0. We just subtract them. So the first one, that one's a little bit easier. So x minus 4. These next two are a little more complicated because we have to take x minus, and then we have to make sure that we put that in parentheses, 1 plus the square root of 5. Because we don't want to subtract just the 1, we need to subtract the entire thing. So that came from x plus the square root of 5. That's our second term, our second binomial. And our third 0 would be x, still minus, but this time we're going to have 1 minus the square root of 5. So we got a lot of algebra to do. The first thing we have to do is we have to distribute the negative to both parts of this binomial inside here. And then we have to distribute the negative here to both parts as well. So we'll leave the first part alone. That will just be x minus 4. Then we distribute the negative. So the x stays there. Negative times 1 is negative 1. Negative times the square root of 5 is negative square root of 5. Bring down the x. Negative times 1 is negative 1. And negative times negative square root of 5 is plus the square root of 5. So now we have a binomial, a trinomial, and a trinomial. And we have to multiply, and we're going to start multiplying this trinomial together because a lot of terms will drop out. So I'll start with the x here. Actually, let's start by writing down the binomial up front, which is x minus 4. We want to make sure we keep that. So x times x is x squared. X times negative 1 is negative x. X times the square root of 5 is x, or plus x times the square root of 5. Then we have our negative 1. Negative 1 times x is negative x. Negative 1 times negative x is positive 1. And negative 1 times the square root of 5 is negative square root of 5. And then our last term, we have the negative square root of 5. Negative square root of 5 times x is negative x square root of 5. And then we have negative square root of 5 times negative 1 is positive square root of 5. And then negative square root of 5 times the square root of 5 is negative square root of 25. And then we can simplify this. We can simplify all this inside this parentheses here. We look at our combining like terms. So our binomial up front stays x minus 4. And we only have one term in all of this that's x squared. So we're going to write down and just have it be x squared. And then we have our linear term, which is negative x, and negative x, which becomes negative 2x. And then we're going to have a bunch of things that cancel out. So we have a positive x to square root of 5 and a negative x to square root of 5. So those drop out. And then we have a negative square root of 5 and a positive square root of 5. So those will cancel each other out. Then we can bring down the plus 1. And we can bring down, actually this is negative 5 because the square root of 25 is 5. So negative 5. Here we can still combine like terms. So we get x minus 4 times x squared minus 2x, and 1 minus 5 is minus 4. And now we have this binomial times the trinomial. X times x squared is x cubed. X times negative 2x is negative 2x squared. X times negative 4 is negative 4x. Negative 4 times x squared is negative 4x squared. Negative 4 times negative 2x is negative 8x. And negative 4 times negative 4 is positive 16. Oh, negative 4 times negative 2, this should be a positive 8x. And now we can combine like terms. We have 1x cubed. The next one we come to is x squared. We have a negative 2x squared and a negative 4x squared, so that becomes negative 6x squared. Then we have a negative 4x and a positive 8x. That becomes positive 4x and positive 16. And so this is the polynomial of least degree where we started from with our 3 degrees up here, with our 3 zeros up here. And we can take a look at the graph. I'll turn off the one from previous, so we can look at this graph, and we can see that we have our zeros. This one, negative 1.236, that is 1 minus the square root of 5. And 3.236, that is 1 plus the square root of 5. And then we have our 0 of 4, which we were given in the original problem.